Hey everyone. So we are the group presenting magnetic circuits. Our group consists of Ethan Graham, Leo Lerma, myself, Samuel Tando, Matthew Reyna, and Firash Kanem. Now, as a disclaimer, this is an assignment for Dr. Kate Davis's Ecen 340 class uh, at Texas A&M University in fall 2022. So what is a magnetic circuit? You could think of these as a good old electric circuit. It's a closed loop system where rather than a current, a magnetic flux flows. These circuits typically consist of a metal core made up of steel or permeable metal. That core has a wire coil winding on it, creating a magnetic field. As you can see from the right, these circuits could have multiple coils winding on it, and it could also have gaps on them, which induce fringing. Now, air gap fringing is when a magnetic flux is forced to the outside of the gap, which makes the gap bigger, as you can see from the figure on the right, bottom right, goes like that. When neglecting fringing, the area of the gap or gaps is equal to the area of the core. Now, on a magnetic circuit, you could think of the voltage source from an electric circuit as the MMF, which is on the magnetic circuit side. Now, MMF is turns N noted by N times the current I, which is equal to the reluctance, which is noted by a big fancy R, times the flux, which is noted by the Greek symbol phi. This is one of the main equations utilized when solving problems with magnetic circuits. Now I'll pass it on to my groupmate, which will dive into the components of solving magnetic circuits.
Hi, my name is Matthew, and I'm going to be talking about the components to solve a magnetic circuit. So a lot of the components that are given are usually the length, the number of loops the number of times the wire is wrapped around the core itself, the permeability, as well as the area. A lot of the components that we're usually going to be looking for to find are the flux, which is considered to be the total magnetic field which passes through a given area, the reluctance, which is simply the resistance on a magnetic circuit, the flux density, which is the force passing through each unit of area, and the magnetic field intensity, which is the measurement of how strong the magnetic field is. A lot of these formulas can be interchanged within themselves and used to find different sets of components that may not be given.
So just some examples of magnetic circuits used in the real world. They're used in many different scenarios. First one will be generators, which generators use an electrical magnet, create electricity by rapidly spinning a turbine to produce a massive current, and this helps us like power a lot of the electricity we use today, and yeah, it just helps run your homes, run everything. Yeah, and then the next step is electric motors, which contain electromagnets through the shaft, which allows current to flow through the motor, and then shaft rotates and moves to other parts of the system. Okay.
I'll be looking more closely at practical uses of magnetic circuits, specifically using air gaps. This would be electromagnetic relays would be a good example of this. So electromagnetic relays are used as heavy-duty switches, switches that are controlled by an electric current rather than switches controlled by a mechanical lever. You can see on the bottom photo here, there is a magnetic circuit with an induction coil wire along with an armature. So the armature is above the magnetic coil. And when there's current passing through the coil, it magnetically attracts the armature, which will push a connector to complete a different circuit system. So the main practical application or the main positive benefits of an electromagnetic relay is that the input and the output are entirely isolated from each other. So a DC relay with an induction coil using a DC current to turn on the magnetic flux. This can be used to connect an AC system, and vice versa. An AC relay can be used to connect a DC system.
Magnetic circuits are also used in medical science. There are applications of magnetic force in medical science. X-ray and scanning devices rely on electromagnetic actions. MRI scanners are magnetic resonance imaging devices, and they are used in hospitals to create 3D images of body parts.